Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, as you can see, we're zipping right along with our ST70 build. This has been a fairly long build series because I'm really trying to put the details in there for new DIYers. And for you guys that, build a lot of these amps yourself, I'm sure this is super boring, but hey, that's okay. Part of what I do on this channel is encourage new DIYers to build stuff like this. And I really think this is a great starting point for a DIY hobbyist to do as their first build. You end up with a really nice amp that hits way above its price point, which is kind of the point of building kits to start with. And we're tweaking things a little bit, I think, to make it more hi-fi than what it was back in the 60s when this kit first came out. Plus, this board to me is a big upgrade off of what it came with originally, and we're doing some grounding different. Plus, I think we're making it safer by grounding the chassis and using a 3-wire power cord. Well, again, I wanted to kind of refresh the startup portion of the final series of videos, and so let's get busy finishing this amp up. Okay, so we pulled the 6.3 volt heater daisy chaining off of pin 2, pin 7 on this socket, and you see we got a twisted pair of solid core wire. Comes up, we got it tucked up underneath this lip here, runs along here, comes down to these two terminals on this front octal socket, and we soldered those in the bottom holes. Then in the upper holes we ran another pair of twisted wires from here down, and they split right at the board, and then one goes to that filament, one goes to that filament. On the other side, again, we go from pins 2 and 7 over here, pull them up here away from these signal wires. That's the key, is keep them away from any of these signal wires. Comes up, tucks over in the corner, brings across, then goes to this terminal and this terminal on this octal socket on the front, into the lower or the closest to the front panel holes. And these outer holes, we've got another pair of twisted wires that comes over, and again they split right at the board, and then one goes to this filament terminal and one goes to that filament, and one goes to this filament terminal, the other one goes to that filament terminal. One goes to this filament terminal. One goes to this filament terminal, and the other one goes to this filament terminal. Say that 3 times real fast. Anyway, that gets the heater wiring up here to the driver board that will power the heaters of these 3 tubes. And then we also have 6.3 volts on this octal socket, so we can measure our heater voltage here on the front of the amp without having to go in it. Which, you may not do that very often, but got to run these up by these terminals anyway. We might as well use them. Then we pulled this yellow wire from the output transformer, and the instructions say to run it down low, right up next to all this AC wiring, and that just didn't seem like a great idea to me either. And so I am using some of the 3D space in the amp, and so we came up and over and then down to the feedback terminal on the board, and the same thing on this side. We came around, kind of get a little distance here between the choke and this wire, comes up here, and there's a feedback going into the front of the board, because again, this is a signal. It's coming off the output transformer. It's the feedback loop, so we don't want to pick up any AC hum. The other thing, if you note, we are running this like at 90 degrees to all this AC wiring, and so that's another way to help eliminate picking up noise, is run wires at 90 degrees to each other. And you can see the same thing back here. So then we came in and soldered this wire here, which is the ground for the driver board, and it comes over here to our star ground point. Now, the last 3 wires we have to hook up, we got to run a ground wire from here, which I'm going to run like along here, and then up, over, come over to the star ground point, and then this one is going to just circle around and come down to the star ground point there. And then the last wire that we have to connect, this is the B plus for the driver board, and it's going to run from here over to this terminal right here that is on the other side of this 2.2K dropping resistor or RC filter for the power for the front end tubes. So let me get those all put in place, and I'll show you what the final wiring of this thing looks like, and then we'll do some initial voltage testing to make sure that we've got negative voltage on all the grids of the output tubes, and that we've got 6.3 volts up here on the heaters and that sort of stuff. And then we'll put the tubes in and check voltages with everything live. So let me get this last little bit of wiring done, and we'll be ready to do some voltage testing. Okay, so here's the last bit of our wiring that we had left. Here's the ground tag point for our cathodes, and it comes over like this to our star ground point. This is the other ground terminal on this octal socket. Comes over here to our star ground point. Again, we also have the ground for the board right there. We put in the last segment. And then here's our B plus that comes from this B plus spot on the driver board. Comes over here to this terminal on the capacitor that's on the other side of this 2.2K resistor. That's our final RC filter for the power that goes to the driver board. So the first thing I want to test is I want to make sure I've got negative voltage on all of these grid terminals before we put the output tubes in and power the amp up. And for this test, you don't need to have the rectifier tube in. So here's a good ground spot right here. And then here's our meter. Put something to prop it up so it's a little easier for you guys to see. Like that. There we go. Got it on our DC voltage. So let me plug in the power cord. Make sure the switch is off when you're plugging it in. And I've got the potentiometers in the middle on the top of the board, the bias adjusters. So we should see 40 to 50 volts of negative voltage on these grids. And then we know we're ready to put the tubes in and start doing some final voltage testing. So again, without the rectifier in it, we do have really high voltage AC here, but there's no high voltage DC. So just make sure you stay away from those two terminals. So let's see if we get some negative voltage on our grids of our output tubes. And there's negative 50 volts. Like I said, let's put it on the grid terminal. Make sure we're getting it through that grid stopper. Negative 50. Negative 48. Negative 50. So our negative bias supply is working, and the midpoint of those potentiometers using this 15K resistor instead of the 27K. We use the optional 15K ones. The midpoint should give you about negative 50 volts, and that's what we're seeing. And that's going to be a nice, really cool place to initialize the amplifier. So I'm going to put all of the tubes in, and then it's really hard for me to show you the voltage tests with the camera going because I'm going to have the tubes upside down and all of that stuff. So I'm going to install all the tubes. I'm going to power up the amplifier. I'm going to adjust the bias. So we're going to be looking for 0.4 volts here, there, and then there, there. You can also check here directly on the tubes. But again, I'm going to turn the amp over. I'm going to, where I can get to the bias adjusters, I'm going to power the amp up. I'm going to go ahead and put my dummy loads on the output. If you don't have dummy loads, hook up some speakers that you don't care about. And whenever you're done testing, unplug the amp and turn the power off so that you don't have some problem with touching something accidentally while you're messing around and you forget that it's powered up. So always unplug it once you're done voltage testing. So I am going to speak for a second, though, about why I like tube rectifiers, especially in a fixed bias amp. One of the things you have to make sure of is that you have negative voltage on the grid before the plate voltage hits the tube. And by using a tube rectifier, you ensure that you're going to get negative voltage on the grids instantly because it's solid state rectified. And having a tube rectifier, it allows for the grid voltage to get stabilized before the plate voltage come in, because as I showed you in another video, this tube rectifier gives delayed voltage to the tubes. I will warn you that not all rectifier tubes are equal. And like we've been testing with this gold lion tube, but even this tube is probably iffy to use in an ST70. It's really pushing the limits of what a 5AR4 tube is capable of dealing with. And you've probably read a lot of complaints people have about these things blowing out rectifier tubes. There is that yellow sheet mod, which I haven't found the need to do yet because I'm using new old stock rectifier tubes. And I've had really good luck with just about any of the new old stock rectifiers. I buy a lot of them that are some of the made in Japan ones, the Matsusuda, I think, I don't know how to pronounce that, but that's a good brand. The RCAs, the GEs, just any of those new old stock ones. Unfortunately, they've gotten really expensive, and you're going to probably spend $100 for a good rectifier tube. And that may sound like a lot when you think, I could buy a JJ for $22 or $23. I can promise you a JJ 5AR4 tube would last about 5 minutes in one of these amplifiers. And so, you're going to be spending probably what these cost, a Gold Lion, or I think those Tube Amp Doctor 5AR4 tubes are pretty good. I've had fairly good luck with the Sovtex, but I have had a couple of bad out of the box of those. And yeah, so just be warned on that if you're going to build one of these, it might be worth investing in a nice rectifier tube just so you don't have problems. So anyway, let me power this thing up, and then I'll come back after I write down all the voltage, and I'll point the different places in the amp that I measured the voltages and what they were, because I think that'll be useful for you. So let me go do that, and I'll come back and show you what the voltages I got were, and then we'll be ready to hook this thing up to the audio analyzer suite and start testing this new one versus the old one that I restored and see if there's any differences. Okay, so I powered up the amp and I set the bias at 50 milliamps on the tubes. And I know the instructions call for 40 milliamps. I like running a little higher bias. I feel like that it will stay in Class A longer, and for a lot of folks, they may never go into the push-pull or Class AB mode that this amp has if your speakers are fairly efficient. So anyway, these voltages were measured with the bias set at 50 milliamps on each tube, or half a volt. And at this point right here, which is the DC voltage off of the rectifier tube, I got 448 volts. And then at this point, after the choke, which is the B plus going to the output transformers, I got 436.5 volts. So then this right here, after the 2.2K resistor, which is going to our driver board, this part right here, got 384 volts. On the plate of the output tubes, which is the blue wire, I got 432 volts. On the ultralinear screen cap, I got 434 volts, and ended up with approximately negative 37 volts on the grids to get them to bias at 50 milliamps. And those are the main voltages you need to check. Now, historically, when I do my own ultralinear amps, I like seeing the voltage here on the screen tap 1 or 2 volts below the plate. And when you directly connect them like this, the voltage is a couple of volts higher. So I may come back and experiment with putting something like a 1.2K screen stopper in the ultralinear tap, but that'll be for some future tweaking. So yeah, everything turned out right where I was expecting. The B plus is a little lower on this new amp than it was on my vintage one, which will change the power output a little bit. The interesting thing was the 6.3 volt really wasn't much lower than on my vintage one. It was still 6.6 volts. And that was on both sides. And so, yeah, I was expecting it to be closer to 6.3 volts, given it's a modern transformer. And that's one of the kind of hypes out there, is the old ones were designed for 117 volts instead of 120. And so they are, these voltages on this stuff is boosted. And I didn't really see that in here. Like I said, the B plus was a little lower coming out of the rectifier. And then the 6.3 volt was 6.6 volts. And I think it was 6.7 on my vintage one, which is kind of pushing the limits of what I like seeing on the heater voltage. But it's right at the limit of plus or minus 10% that they give you on the tubes, and I would rather see them running the heaters a little hotter than cooler. I don't like seeing them go under 6 volts, and something like 7 volts is just way too much. So I think I'm going to just continue to kind of risk it on my vintage ones being a little higher. So anyway, that wraps up the testing on the voltages. Everything seems to be working like it should. I'm going to go plug this thing into my system, burn it in for a few hours just to make sure that everything's nice and settled and that it sounds good. And in the next video, we're going to do a back-to-back audio analyzer suite testing on this new production kit versus the old early vintage, cloth wired transformer unit that we did earlier that performed so well. Going to use the same tubes in both of them, and so that won't be a variable, and it's going to be interesting to see how these two compare to each other. So this looks like a great place to wrap up this build series, and thanks for watching. So that wraps up another segment of this ST70 new kit build. Want to add that this is not sponsored by Tubes for Hi-Fi, nor do I have any affiliation with them. This kit was drop shipped to me by a viewer that commissioned me to build this for them. Now, I don't normally do like kit builds professionally, so yeah, I may or may not be willing to do it in the future. We'll see what that's all about, but for now, we're just doing this one for the channel and for some fun. I want to thank all you Patreon supporters and folks that make donations at my website. If you find this information useful, please consider joining my Patreon or making a donation at my website. It really helps fund future projects and keeps this channel going. I also want to thank you regular viewers and especially you subscribers. If you haven't subscribed yet, please click the subscribe button. It's not a big deal to do. It doesn't cost you anything, and it helps the channel grow and other people see my fun content. So that's going to wrap this up. Until the next segment, have a nice day.